Welcome to Study Loop.
So in this problem, we are given this reaction here, and we are given with the partial pressure of each of the reactants and products at the equilibrium. So in first part of this problem, we have to calculate the Kp value for this reaction. So first we have to write down the expression for the Kp value for this reaction, and the expression will be the product's partial pressure over the reactant partial pressure. That means P PCl5 over P of PCl3 times P of Cl2. So this is the equilibrium constant expression in terms of pressure for the reaction given, and we are already given the values here, so we just need to plug in the values. So the PPCl5 value is 1.3, and then partial pressure of PCl3 is 0.124 times the partial pressure of Cl2, which is 0.157, and from here, just solving this, we can find the value of Kp, which is 66.776, and this is the Kp value for the reaction given. Now in part B of this problem, we have to say if the equilibrium will favor reactants or products. So from the equilibrium constant value, we can see that the value is very large than 1, and as we know that if the equilibrium constant value is very larger than 1, that means that equilibrium will favor the products, and that's why in this reaction the equilibrium will favor the product PCl5. And then in C part of this problem, we are asked to find out or calculate the Kc value for this reaction. So we know that there's a relation between Kp and Kc, which is Kp is equal to Kc RT del N, where Kp is the equilibrium constant in terms of pressure, Kc is the equilibrium constant in terms of concentration in molarity, R is the universal gas constant, and T is the value of the temperature in Kelvin scale, and del N is the um, value of or the difference of the number of molecules of products and reactants. So here we know the value of Kp, which we have just calculated. We know the value of R, which is a constant, and we know the value of T. So the value of T here is given as 450 K, and we know the value of R as 0.08206 liter atm per mole Kelvin. So now we just need to know the value of del N, and from the balanced equation we can see that um, the number of molecules of products is 1, and the number of molecules of reactants is 1 plus 1, which is 2. That means the number of molecules or the value of del N here is 1 minus 2, which is minus 1. So if we just, so the value of del N here is minus 1. Now if we just rearrange this equation, it will be, we can find the value of Kc just by putting Kp over RT whole to the power del N. So the value of Kp is calculated as 66.776, and the value of R is 0.0821 times the value of temperature, which is 450 K. So we have to make sure or remember that the temperature value is always in Kelvin. So if it is given in degrees Celsius, we have to convert it to Kelvin scale just by adding 273 to the degree Celsius value, and we are given and we have calculated the value of del n as -1. So if we solve this, we will get the value of Kc as 2.467 times 10 to the power -3. So this is the value of Kc for the reaction given.